The purpose of this example is to show you how to compute the set of Pareto optimal allocations in a more interesting economy. So suppose that we have 10 consumers and all of them have preferences of the form ui of qm equals to alpha I, where alpha is some positive coefficient, logarithm of q plus m, again with alpha I greater than 0, and then have wealth w, I. And also suppose that there are 10 firms, just for the sake of example, and each firm has a cost function of q beta j q squared. That's it, with again beta j greater than 0. Now let's characterize the set of Pareto optimal allocations. So the first thing that we need to do is derive the implications of the three properties. Property 1 says that we want to look at the difference in marginal cost across firms. Now notice here that the marginal cost for firm J is equal to 2bjq. That means, because the marginal cost at 0 is 0, that we're going to have interior solutions for any positive level of production. So this implies first interior solutions, and then we know that at interior solutions the marginal cost has to be the same by property 1. So we know that 2bjq is going to be equal to 2b k, so there's a j there, qk, the marginal cost of firms j and k has to be the same, which implies that qj, let me put an f here so we don't we distinguish with the notation for consumers, qjf divided by qkf has to be equal to the ratio of bk over bj. So this is the first property that needs to be satisfied of the application of P1 for any pair of firms j and k. Notice what this means, that the ratio of the output of Q of firm j to firm k is inversely proportional to the ratio of their parameter that affects the marginal cost. That makes a lot of sense. The higher this marginal cost parameter for j with respect to k, the lower that ratio becomes. Now let's look at the implication for property 2, which has to be is the analogous with respect to the marginal benefits. Now notice that the marginal benefit for any consumer here is just alpha I divided by q, and that marginal benefit is infinity, when q goes to 0. So that implies again that we're going to get interior solutions, and second, that this alpha I over qiz has to be equal to alpha j over qjz. That's just the formula of marginal benefit for consumers I and j, which implies that in this case the ratios qiz divided by qjz has to be equal to alpha I over alpha j. In other words, the ratios are proportional to the ratios of this parameter that affects the marginal benefit of consuming the good q. Now the third property is going to tell us, we know that we are at interior allocation, so that marginal benefit of I has to be equal to marginal cost of j for all I and j. And if we substitute, we can do it for any I and j, but for example, let's do it for firm 1. Well, let's do it for any firm j. Alpha I divided by qic has to be equal to 2 beta j qfj. That is going to hold for any pair of consumers and firms. So now we have derived the properties that have to be satisfied, but we are not quite done computing what exactly is the Pareto optimal allocation. We need to do that next. And the key is to remember feasibility. I'm going to put a line here. We know that the allocation is feasible, so look at the feasibility constraint. Implies that the sum over the amount consumed by consumers has to be equal to the sum over of the amount produced by firms for good j. Now I'm going to expand this with algebra by noticing in this formula, using this formula with k equals 1 for every consumer. So this is equal to the sum over consumers of alpha I divided by alpha 1 q1z, and this is equal to the sum over firms, using the same trick, of beta 1 over beta j Q1F. Now I'm going to call, these are just a sum of constants that are parameters of the problem, so let me call this alpha, and let me call this beta. Okay, and now what do we have? We have two equations with two unknowns. So it implies that equations are this A Q1C equals B Q1F. That's one equation that we have. And the other equation that we have is this one for the case of the first firm and the first consumer. So it's alpha 1 divided over QC1 is equal over 2 beta 1 for the first firm. Now we have two equations with two unknowns, the production for the first firm and the first consumer. Once we know this, we know how to back out the production for any other firm or any other consumer from this equation. So if we solve this, we have solved the entire allocation. And if you do a little bit of algebra, you're going to get that Q1F is equal to square root of A alpha 1 divided over 2 B beta 1, and that Q1C is equal to square root of B over 2A alpha 1 over beta 1. And again, from that, you can back out all of the quantities. So you have a complete description of what gets produced in good Q and what gets produced in good M. You may be wondering yourself, what about good M? Well, we know that distributions of good M do not matter. Okay? And we also know that they don't, the amount of W that we have doesn't show up in the formula of Pareto optimality. We showed that when we derived the formulas last time. The amount of endowment of good M in the economy doesn't really matter. And let me emphasize that this is because in this model we're assuming that M can become negative. So therefore we're never binding on how much good M we have in the economy to determine what's the optimal amount to produce. If we were to make the model more complex by removing that aspect of it, we would have to do a lot more math tricks to characterize the Pareto optimality allocation. No economics will change, but we'll have to do a lot more algebra.